Okay, so this time, we rotate the shape around the x-axis. So take a look at what it says. The region between the graph of, f of x plus whatever, 2 plus x cosine x, and the x-axis over the interval -2 to 2 is revolved about the x-axis. And when we say that, we put this symbol on it, revolved around the x-axis. It's like a circular arrow. It's like a circular arrow, okay? So here, revolved around, okay? Find the volume of the solid using a calculator. So when you do revolve it around, you get the shape to the right, right? That three-dimensional shape to the right. And the cross sections here are going to be circles. And like we said, the radius of that circle is just f of x because it goes from the x-axis up to the curve. Okay, so the volume, okay, so the area then is just pi f of x squared. That means the volume is going to be from -2 to 2 pi, and we like to put the pi outside so it doesn't interfere. What's f of x? 2 plus x cosine x squared dx. And this you can't even integrate by hand. You have to put it in the calculator. 52.429. You'll learn later how to integrate it by hand. Okay? All right. Now, what if you have two shapes? What then? Dun, dun, dun. Yep. What if you have two shapes?
So the fact that we are now finding our own integrands shouldn't come as a total surprise.
Okay.
Is it just that the speakers distort?
Yeah.
Unfortunately, this technique does get a little trickier. While rotating one function around an axis gives us one type of solid, if we take the area enclosed
look at this one.
functions and rotate that around an axis, that can give us a different kind of solid, whose cross sections are not circles, but rather things called washers, inner radius, and one from the axis.
Okay, so when you rotate that one, okay, you're going to have a funnel-shaped empty space in between. And now when you take cross sections, they look like washers. Okay, so do you guys know what a washer is? It's not a washing machine.
No.
It's like these little metallic discs that you use for nuts and bolts and stuff, okay? Basically, it looks like this. So when you have this, okay, then you have to take the area of the shaded region in green, which means you have to do pi r squared of the big circle minus pi r squared of the little circle. And that's why we teach you geometry. Okay?
The washer will also change as it moves through the solid. And both the inner and outer radii change according to these two functions.
Okay. So
Let's take the functions y equals x squared and y equals x. There is an enclosed area here between x equals 0 and 1.
So let's do our own. Here. All right, let's do our own. Next one. So this is called the washer cross section. And when we have that situation happening, the area is going to be pi big R squared minus pi little r squared. So now,
big R is R.
hang on. So take a look here. If you start from the x-axis, big R is from the x-axis to the farthest or the outside function, and little r is from the x-axis, or it's from the axis of revolution to the closest or the inside function. You always start from what you're rotating against and you go out. Farthest function is big R, closer function is little r. All right? So, let's take a look at this one. The region in the first quadrant enclosed by the y-axis, and the graphs of y equals cosine x and y equals sine x is revolved around the x-axis. So again, I put this so I know that it's revolving around the x-axis. Okay, when you revolve it, you get the shape to the right. Do you see how the empty space in the middle, when you revolve this, is going to generate an empty funnel-shaped space in the middle of the solid, okay? So, you're told which functions they are, you're given the graphs, it's up to you to distinguish which of these is cosine and which of these is sine. So, the top one, is it cosine or sine? Cosine and sine. Okay, so now, the radii. How do you do the radius? Okay, so we need to find what big R is and we need to find what little r is. Big R, what's the axis of revolution? What is it revolving around? It's the x-axis. It's revolving around the x-axis. So you're going to go from that axis up to the farthest function. That's big R. It's cosine x. Little r. What's the axis of revolution? X-axis. Okay? What is it revolving around? The x-axis. So it goes from here to the closer function. That's little r. Little r is sine x. So I'm going to ask you again, what's the axis of revolution? X-axis. Okay? Because it tells you here. It's being revolved about the x-axis. Okay. Volume is pi big R squared minus little r squared dx, and it goes from 0 to the point of intersection, this green dot. You have to find the point of intersection. If you've got your calculator and it's something you need to graph, you graph it, you find the point of intersection. But where is cosine x equal to sine x when x equals what? Pi over 4, right? Because that's where cosine x and sine x are root 2 over 2. So we're going to go from 0 to pi over 4. Okay? And this gets you, actually pi over 2, because this whole thing ends up being a half. Okay?
Where did you get the pi before the cosine?
Because it's pi big R squared minus little r squared. Because, yeah, it's pi r squared. Okay, so most common mistake is people forget the pi. Me included. Okay, sometimes I forget the pi. Don't forget the pi. Okay, now, we're going to stop here today. You're going to do the homework, which is from the book. Now, only do the ones where it says that it's being revolved around the x-axis. Don't do the other ones. Cool? Thank you.
Oh yeah, the next one, example 5
Yeah.
is being